So in this video, we're going to learn about displacement against time graphs. The reason that we're going to do this is graphs are a very effective way of visualizing and describing motion. So here is a blank graph with displacement or position, doesn't really matter which, on the y-axis, and then time on the x-axis. And so by analyzing lines that we draw on this graph, we'll be able to see how an object's position changes with time. So to help explain displacement versus time graphs, I'm going to use this simulation here created by the University of Colorado. This is what's called a PhET simulation, and you can look it up for free online if you'd like and use it yourself. And so, the way that this simulation works is there's a man who's standing at position 0 at the moment. And over time, the man will move. So he might move down to the tree at position -8, or move to the house at position 8. And then what the program will do is graph the man's movement with time. So let's have a look at this. If I just make my man stand still, then this is what his motion looks like. So you can see that it's just a horizontal line from time 0, and it remains at position 0 throughout the whole motion. If the man, rather than standing still, was instead to walk very slowly, let's suppose 1 meter a second, towards the house, then the motion would look like this. So as you can see, the line is a graph which slowly goes up, and then once he reaches the house, it goes flatline again, and the man is still. So that's showing the position is slowly changing with time, and then the position remains constant as time continues passing. Let's suppose instead of this nice smooth movement, instead the man was to suddenly go from one place to another. So he starts at 0, and then he suddenly moves to 1 meter and then stops, and suddenly moves again and then stops. That's shown in this graph here. So we have a very sudden movement, then a stop. A very sudden movement, then a stop. And then he could go back to the middle and stop. We'd have the flat line again. And then if he was to go backwards in the other direction and have a negative displacement, it would look like this. We'd have this negative bump going downwards. And so this graph shows us what it would look like if somebody was to move and then stay still. Slope, or very steep slope, and then stay still. Now let's have a look to see what would happen if the man was to walk at different speeds. So we're going to start out with the man walking very slowly to the house like this, and then he stops. Now what I'm going to do is just zoom out on that motion so we can see what it looks like, and we can see it's a nice gentle slope. But then if I reset it, do it again, and this time I have the man stay still and then very suddenly walk or run very quickly to the house and then stop. Now we see that we have a much steeper slope going upwards and then a flat line. And so what I'm trying to show you here is that the slope of the line is directly proportional to the speed at which the man is running. So if there's a very shallow line, that means very slow velocity or a very low speed, whereas if it's a very steep line, then that means very high speed. So you also might ask, what would happen if we had a negative gradient? Well, if you have a look here, if our man is just slowly running backwards, then we have a negative gradient. So, if we have a negative gradient that goes down, that just simply means the person is walking towards the left or is moving in the other direction. And the gradient of the slope still indicates the speed. So if it's a very steep negative slope, then that would indicate that we have a very high speed moving backwards. So, to summarize all the points in this video, if on a displacement versus time graph there is a flat line, then this indicates that the object is not moving. A negative displacement indicates that the object has moved backwards, and zero displacement means the object is at our origin, whatever we call 0. Then the gradient of the line indicates the velocity. And if you have velocity in the negative direction, you're moving backwards, then you have a negative slope of your line. So, now that you've learnt all this, you should be able to interpret displacement versus time graphs.